You call your bank, you're expecting hold music and a human. Instead, a voice says, "Hi, I can help you with that. Can you briefly describe the reason for your call?" So you talk, and it listens, and somehow, it understands. Not a human, not a script matching keywords. An AI that heard your voice, pulled out the meaning, and responded in something that sounds almost exactly like a person. That moment, heard by millions of people every day, is one of the most complex things AI does, and most people have no idea how it works. Today, we're going to fix that. Here's what makes this so hard. Sound isn't text. When you speak, you're producing a wave, a physical vibration moving through the air. Your microphone picks it up as a stream of numbers, thousands of them, every second. No letters, no words, just numbers representing pressure changes in the air. And that's just the first problem. The second, everyone sounds different. Different accents, different speeds, different voices. A word said by a child sounds nothing like the same word said by a grandparent. Oh, and background noise, music, traffic, other people talking. It's all mixed in with your voice. So how does AI find the words hiding inside all that noise? Quick quiz before we go further. Pause and think about this one. In the next few minutes, you'll see exactly how AI turns a wave of noise into words, and then how it turns words back into a voice that sounds almost human. Step 1. Clean up the noise. Before AI even tries to understand what you said, it filters the audio. It learns what background noise looks like and subtracts it. What's left is mostly your voice. Step 2. Slice it up. AI doesn't process your whole sentence at once. It breaks the audio into tiny slices, each one just a fraction of a second long. Think of it like frames in a film. Each frame is one snapshot of sound. For each slice, it looks at the pattern of frequencies. How much high-pitched sound? How much low? How much in the middle? This creates a kind of fingerprint for that moment in time. Step 3. Match the fingerprints to sounds. The AI has been trained on thousands of hours of human speech. It's learned what the fingerprint for the sh sound looks like, what looks like, what e looks like. So it goes slice by slice, asking, what sound does this fingerprint most likely belong to? Step 4. Build the words. Once it has a sequence of sounds, it uses a language model, the same kind of technology that powers ChatGPT, to figure out which words those sounds form, because some combinations make sense and some don't. Ice cream makes sense. Ice scream doesn't. The language model helps the AI pick the most likely real words from the sounds it heard. That whole process, from sound wave to written words, happens in under a second, every time you talk to your phone. Now flip it around. How does AI turn text into a voice? Early text-to-speech systems worked like a jigsaw puzzle. Engineers recorded thousands of tiny sound fragments, every syllable, every transition, and stitched them together on demand. It worked, but it sounded robotic. Because real speech isn't just syllables stuck together. It has rhythm, emphasis, emotion, the way your voice rises at the end of a question, the tiny pause before you say something important. Modern AI does something completely different. It's trained on hundreds of hours of a real human voice, reading sentences, telling stories, answering questions. The AI doesn't store the recordings. It learns the patterns, the shape of how that person speaks. Then, given any new text, it generates a brand new audio wave from scratch that matches those patterns. Here's a quick check. See if this one clicks. That's why modern AI voices sound so natural. They're not recordings. They're not stitched fragments. They're generated note by note, wave by wave, guided by everything the AI learned about how a human sounds. So why does this matter to you? Because voice AI is quietly becoming the interface for everything. When you dictate a message instead of typing it, that's speech recognition. When your GPS gives you directions, that's text to speech. When you call a company and a voice asks you to describe your problem, that's both, working together in real time. And it's getting better fast, not just at understanding words, but at understanding tone, intent, even emotion. The gap between talking to a machine and talking to a person is closing. And knowing how it works means you're less likely to be surprised, and more likely to use it well. You don't have to be impressed by it. You just have to understand it. Next week, we're looking at something you do dozens of times a day without thinking about it. Reading. Specifically, how AI reads. Handwritten notes, scanned documents, old photographs of text. How does a machine look at an image and extract the words? That's next week. If today's video clicked for you, subscribe so you don't miss it. And if you've ever been genuinely impressed or genuinely frustrated by a voice assistant, drop it in the comments. I read them all. See you next week.